الزملاء الأعزاء، عمتم مساء جميعا. حقيقة يسر شبكة وقاية النبات في اتحاد مؤسسات البحوث الزراعية في الشرق الأدنى وشمال إفريقيا أرينينا ترحيبا بكم جميعا في هذه الندوة الإلكترونية بعنوان المنصة العالمية للمكافحة الحيوية بالعافيات، خال من المضادات الحيوية، قائم على العلم، جاهز للتطبيق. نبذة بسيطة جدا ونترك المجال بعد ذلك للبروف صباح. حقيقة تعد مقاومة مضادات الميكروبات اليوم واحدة من أكثر التهديدات العالمية إلحاحا للصحة العامة والأمن الغذائي والزراعة المستدامة. وقضية العافية تعود العافيات البكتيرية، وهي فيروسات تصيب البكتيريا وتقتلها بشكل طبيعي للظهور مجددا كأحد أكثر الحلول الواعدة لمواجهة هذا التحدي. وتتميز العافيات حقيقة مثل يعني باقي الميكروبيال ايجنتس حقيقة بدرجة عالية من التخصص، واللي هي مع يعني تأثير قليل جدا أو شبه معدوم على البيئة، وكذلك تتوافق مع استراتيجيات الإدارة المتكاملة للآفات الزراعية إذا ما استخدمت للتخلص من بعض أنواع البكتيريا التي تسبب أمراض للنباتات. وعلى عكس المضادات الحيوية واسعة الطيف، تستهدف العاديات البكتيريا الضارة بشكل انتقائي selective and specific، مع الحفاظ على اللي هي البنفيشيال مايكرو اورجانيزم، مما يجعلها طريقة مثالية للمكافحة الحيوية في الزراعة، سواء في الزراعة أو في مجال الصحة العامة. كلنا أمل حقيقة أن تقدم ندوة اليوم، وأجزم بذلك إن شاء الله سبحانه وتعالى، أن تقدم ندوة اليوم جيلا جديدا من الابتكار القائم على العافيات، يهدف إلى الانتقال من مرحلة البحث إلى التطبيق العملي والتجاري. ومن خلال الجمع بين أحدث الإنجازات العالمية واستراتيجيات التطبيق العملي، تهدف محاضرة اليوم إلى إظهار كيف يمكن لمنصة عالمية للعافيات أن تسهم إسهاما مباشرا في بناء أنظمة غذائية أكثر مرونة وأكثر سلامة، وتحسين صحة الصحة العامة، وتعزيز الإدارة البيئية والزراعية المستدامة. حقيقة متحدثنا اليوم يعني عالم جليل بكل معنى الكلمة، وهو الأستاذ الدكتور صباح جاسم، وسأتحدث عن المنصة العالمية للمكافحة الحيوية بالعافيات، خال من المضادات الحيوية، قائم على العلم، جاهز للتطبيق. يعد البروفيسور جاسم أحد أبرز الخبراء عالميا في التكنولوجيا الحيوية الطبية الميكروبية، ويتمتع بخبرة تزيد عن 35 عاما من البحث والابتكار والقيادة في مجالات المكافحة الحيوية بالعافيات والتشخيص الميكروبي السريع وعلاج الأورام وتطوير المبيدات الحيوية للتطبيقات الزراعية أو في مجال الزراعة. وهو المؤسس والرئيس التنفيذي لشركة Applied Bioresearch، كما يشغل منصب مدير البحث والتطوير في شركة كاموليون، حيث يقوم بتطوير منصات التكنولوجيا الحيوية من الجيل التالي لمعالجة بدائل المضادات الحيوية وحماية المحاصيل المستدامة، مما حقيقة يأتي بالنفع سواء على صحة الإنسان والحيوان وكذلك البيئة. حصل البروفيسور صباح على درجة الدكتوراه في الأحياء الدقيقة الطبية من جامعة نوتنغهام وجامعة لوبارا في المملكة المتحدة. وحقيقة خلال مسيرته أشرف على أكثر من 200 باحث حول العالم، وهو المخترع المسجل له 46 براءة اختراع دولية باسمه، كما ألف وشارك في تأليف العديد من الفصول في الكتب العالمية المعروفة. وكذلك هو محرر لكتاب اللي هو Bacteriophage Practical Applications for Nature's Biocontrol. And so far, so I know that this book, I think, is already published in Springer in اللي هو 2017. وهذا المرجع حقيقة يعد مرجعا أساسيا في تطبيق العافية في الزراعة والصحة العامة على مستوى العالم. شغل البروف صباح حقيقة عدد من المناصب الأكاديمية المرموقة في عدة جامعات عالمية كجامعة نوتنغهام، وأستاذا مشاركا غير متفرغا في جامعتين في كندا، غولف ووينزور، وأستاذا زائرا في جامعة بوترا ماليزيا، حيث أسهم حقيقة في نقل المعرفة الدولية في التكنولوجيا الحيوية وعلم الأحياء الدقيقة التطبيقي. كما شغل منصب مدير بحث في أحد شركات الأدوية في ألمانيا. وأخيرا وليس آخرا، وتقديرا لهذه الاسهامات، وقد ذكرت قليلا من كثير حقيقة عن البروفيسور صباح، وتقديرا لاسهاماته العلمية وقيادته في العالم العربي، صنفته مجلة Arabian Business ضمن أفضل 13 شخصية في قائمة أقوى 500 عربي تأثيرا في الشرق الأوسط عام 2011. The floor of yours, the screen of yours. تفضل دكتور صباح، يمكنكم you can start your presentation إن شاء الله. After that we will open the discussion session. فأهلا وسهلا بكم دكتورنا العزيز. فلتبدأ هذه المحاضرة القيمة إن شاء الله، وتطلعنا على ما في جعبتك إن شاء الله سبحانه وتعالى. وكلنا أمل أن يستفيد جميع الحضور، وأن نتبادل الأفكار والمعرفة، وننهل من هذا العالم الجليل حقيقة. دكتورنا العزيز تفضل مشكورا.
شكرا دكتور. السلام عليكم. The slides appear or
Yeah, appear so clear.
okay. So thank you very much, Professor Firas, for the introductions. I don't know if you want me to speak in Arabic or English. Doesn't matter for me.
You can speak both.
Both, okay.
As I said before, you can mix between Arabic and English as you would like.
Thank you. Now, the problem is multi-drug resistance bacteria and global warming. Today is our lectures on bacteriophage and what the relationship between the multi-drug resistance and global warming. Multi-drug resistance actually started the problem approximately 1940s. Before 1940s, 1922, phage therapy has been used worldwide, in particular in Georgia, Tbilisi, Soviet Union before, where there was no any antibiotic to treat patients or any bacterial infection at that time. Then after the discovery of antibiotic by fluke, by mistake of the a scientist left his petri dish during the weekend or during the Christmas time and returned back from Scotland, and he found fungus that infected bacteria, and then discovered penicillin. And then from that time started the pharmaceutical industry doing a lot of formulation for chemical antibiotic. And that took approximately several years to reach a stage where first time introduced antibiotic for the not only for the human as well as for the animal. Merck has introduced it in 1948 to treat animal. Then after the treatment of the animal, they found out that the animals start to increase the weight, and that reduce as well as the food they eat. And then they discovered that probably a good idea to envisage or introduce antibiotic in their food as well. So that time started pharmaceutical industry not only sell the antibiotic to the human, but they start as well to give it to the animals. If you take like example, a bird chicken, 1950, approximately 70 days weight of the chicken, adult, approximately 1 kilo and 400 grams. If you come today, it's 47 days, only 47 days increase the yield of the meat approximately 2 times. That means the antibiotic not only used for the treatment as well as for growth promoters. And growth promoters, that mean increase the yield of the meat, increase the yield of the milk, and increase the yield of the healthy of the animal. But that has accumulate with the resistance, because when you give antibiotic random into the bacteria itself has a mutation. So get some mutation during the process of introducing antibiotic to the animal in huge amount that cause them resistance. So approximately 25 to 75% of antibiotic today administered for food lot animals. That's big amount if you think about it, for the feed, for the treatment, for everything. Then where is going to be the end? Going to be end into the environment, into the water, into the groundwater. That create a lot of antibiotic resistance. Now, if you think about, there are approximately very large, big number of antibiotics have been used for treatment of animals. Not only treatment, as well for growth stimulant and prevention. So the antibiotic used for the animal for three things: treatment, growth promoter, and prevention. What mean prevention? That means if you have one cow in about 100 cows, this one cow is sick by any bacteria, so they give the other 99 of the cows healthy the same antibiotic. That one called prevention. Then after that, they give them as well a growth promoter. So that increase approximately 50% of our antibiotic used by human has been used for the animal. That means a huge amount of antibiotic. And this was the problem how it started. It started from the animal. Not only for the animal, antibiotic has been introduced, as well as introduced for the agriculture. So the agriculture as well, they use approximately 15% of antibiotic for the agriculture use, for mycoplasma, for example. So what we have approximately 5 to 10% of all antibiotic produced by pharmaceutical industry, they use for the human, and the rest for the animal and for the plant. So if you consider that means we are playing like an evil way in the environment, alienating the bacteria to be resistant. Today, all the antibiotic, just you name it, has been used to treat animal, growth promoter, and prevention.
Yes.
For example, what happened now? If you think about just this slide will show you the problem. We have two problems facing in the world. We have antibiotic introduced to the animal daily by animal feed, prevention, or treatment. And there is a phage, lysogenic phage. Now we come to the phage. There is two phage, lysogenic and lytic phage. Lysogenic phage already there in the environment. Lysogenic phage, when introduced the antibiotic, lysogenic phage going to occupy the bacteria DNA, but not killing the bacteria, but to transfer the gene horizontal to the bacteria from one bacteria resistant to another bacteria is not resistant, make them resistant in approximately like 40 minutes to 1 hour, sometimes 2 hours, get resistant to the bacteria. And that increase the mutation of the bacteria. This is going to be a big problem.
Can you repeat this point, please? Because it's confused. It's a medicine now.
Okay. What we have?
Sorry.
We have antibiotic.
Okay.
Antibiotic being used for the treatment or prevention or growth promoter.
Okay.
And the animal carry millions and trillions of bacteria in their gut as well as on the skin. Okay. When you introduce the antibiotic into the bacteria, there is lysogenic phage. We'll come to the phage, explain what's mean lysogenic. Lysogenic, that's mean, just want to, okay. Lysogenic phage mean, oh dear. I just want to get rid of it. Okay, that's good. Lysogenic phage mean bacteria, the phage not killing the bacteria. The lysogenic phage, the tool they have only transfer the gene from bacteria to another bacteria. And this is what happened in the world. So when bacteria get resistant to the antibiotic, the lysogenic phage transfer the molecules from the resistance, the segment of the DNA, to other bacteria as well. So that the other bacteria wasn't resistant, now start be resistant and mutated. We'll explain that later on.
So they are carrier.
Yeah. Where we go? Okay. Now, when you take a big picture of our community, what we have farm introduce antibiotic into the animals. Then we have manure, and the manure going to be into the either river or to the fertilizer. Then the any bacteria from the farm going to be into fertilizer, into the to the agriculture farm, as well as to the river. Then the butcher going to take the animal. Animal carry a lot of antibiotic in their guts, in their carcass, the skin. Then going to take the meat to the community, for example, or to the hospital, or to the restaurant, and to the community. And the hospital has already what you call it acute antibiotic resistance. There is already all the hospitals in the world that has bacteria that resistance to antibiotic. They live on the floor, on the wall, everywhere in the hospital. They call it resistant antibiotic, acute hospital antibiotic resistance. So this antibiotic resistance, when take what you call it, any waste of the hospitals, or they get the meat from the butcher, or get the vegetable from the farmers, going to transfer to the patient, as well as to the community. From the community going to be to the sewage, from the sewage to the river. So it's going to be complicated, very complicated community of the antibiotic resistance. It started from the animal, the problem. Don't forget the insects. The insects play very, you call it, transferring of the disease through their head, mouth. The mouth of the insect, approximately there is 10 to the 3 to 10 to the 5, carrying the bacteria, different type of bacteria. Leg and body of the skin of the wing carry approximately between 10 to the 4, 10 to the 6, or 10 to the 5, as well as the gut and the legs. So there is plenty of bacteria for each insect going to be in the community, whether from the hospitals, or from the farm, animal farm, or from agriculture farm. That insects playing transforming of the disease between the community and the hospitals during the sewage system. The sewage system, it's a mix of debris, human flesh, blood, urine, stool of the human patients. That with the bacteria as well as with the insects carry a lot of multi-resistance bacteria to the community, and that we call it antimicrobial resistance. Started from here. So antimicrobial resistance with the insects, with the using of antibiotic resistance in the animal farm, has increased the danger in the world. Has been speculated. This is in theory. In theory, by 2050, we expect like 39 million people from multi-resistance drug bacteria between 2025 to 2050. That means this number has increased during the COVID time. COVID time, that period, approximately 2 to 3 years, the virus infection, COVID-19, make a lot of immune, we call it resistance of the antibiotic drugs. The reason is immune stimulant has been weakened by the COVID, whether from the vaccine or whether it was something else, or from probably depressions. So we have seen from 2021 an increase, rapid increase in antimicrobial resistance from the period of COVID. And that approximately the number of the increase of the death people, approximately 8 million people has been died since 2050. Approximately 1.9 million death, annual death 2050, annual death 2050, 1.9. This is number never seen before. Never seen has been before. Whether you call it with the COVID, whether you call it with the vaccination, whether you call it with the immune stimulant, whether you call it the immune depression of the people, you don't know. But this is what we have at the moment. So we expect, like in 2050, the number of the people that are going to die from very simple operation, like cesarean operation or any wound or anything, there is no antibiotic that time going to be, they're going to die. So the problem has global now. The problem is antimicrobial resistance and food security. We are facing food security as well. Antibiotic resistance has been increased during that time. There we challenge a lot of new chemical, as well as has been introduced into the environment for antimicrobial resistance. All has been failed. So the people now, or the community now, or WHO, they're looking for a solution. And this solution, we need something to return back to where we be before. Where we before there is no that increase of number of the death of the people. Now, the invisible cure within the nature. The bacteriophage. Bacteriophage discovered in 1915 by Frederick Trott. Then the scientist Felix in 1917 has been indicated again. There is something killing the bacteria, but they didn't know what is it, because there is no any electronic microscope at that time. So they start to use the phage for the therapy in 1920 to 1930s, increase the people. They use phage for the therapy, especially in the Soviet Union, Tbilisi, as well as in Western countries. When they discover antibiotic 1940s and start to increase it more in 1960s, that we call it the golden age of antibiotic. That time there were no any antibiotic resistance. Then antibiotic resistance started rising after 1960s. So the people, they know that there is something, a problem with the antibiotic, and then the pharmaceutical company who produce more antibiotic at that time. Since that time, nobody worked for phage as biocontrol or for the biotechnology. 1988, we are the first to start phage biotechnology in the world at Nottingham University. And we have several international patents at that time. One of them, the rapid diagnostic and virus selectivity, and using the phage for the approximate drug resistance, how you figure out if the drug can work or not work using phage biotechnology. So we are the first actually using phage biotechnology at that time. Then after our discovery, 2000 and 2010, 2020, and now, many pharmaceutical companies start to producing phage biotechnology in different way. Since that time, I just give you this figure, what I've been doing that time. We didn't stop at Nottingham University, but we have plenty of patent application. We using for rapid diagnostic, using for genetically engineered reporter bacteria, we're using for selective virus culture, we're using for method for bacterial diagnostic, then as well as phage-based luminescent assay. We have plenty of publication. I choose only few of them that this publication has the most download in the world, because it has a lot of potential for industry. I know I have published a book. So just give you an idea where I come from, what I have been done. since that time. Now the phage. We're going to talk about the phage biotechnology. The phage biotechnology, since that time, several company has been used phage for the agriculture, for human treatment, for animal, for food security, has been all approved by United States Drug Administration, Environmental Protection Agency, regards as safe food or safe ingredient. So it has been potential important to use for the industry. So approximately today, approximately more than 60 company worldwide in the world, they use phage for different application, either for agriculture or human treatment, for animal, for food industry. For food industry, for example, has been introduced to sterilize the milk against Listeria monocytogenes that cause abortion into the ladies. Also, as well as used for the cheese, used for disinfect the meat or vegetable, has been used for agriculture to treat some plant disease, as well as for the animal for mastitis. So it has been recognized. Now phage is recognized everywhere. Unfortunately, there were no any company in the Arab world that use phage biotechnology. Never. This is my surprise. I mean, it's a big surprise. The phage biotechnology at the moment is the key for the future to get rid of the antibiotic resistance and for food security. But unfortunately, there is no any company in Arab world. I would give you an idea about the phage. Just imagine, the phage is the most dominant on Earth. It started approximately 3 billion years with the bacteria. So the only 3 billion years ago on Earth, there was only bacteria and phage at that time. And since that time, the war between bacteria and phage, approximately 3 billion years, that evaluate or give a lot of strength for the phage selectivity on the bacteria, as well as the bacteria learn a lot of tools how to prevent the infection from the phage. I will give you an idea how much today the phage weight in the world. 2 trillion kilograms or 2 billion tons, the phage on Earth, 2 billion tons. That means approximately, if you put all this weight together, if you compare it to the elephant, that means if you collect all the phage on Earth, going to make 333 million elephant, African elephant, the adult one. Each elephant 6 kilograms. Just imagine. Or if you compare that to the human, you're going to be approximately more than 28 billion human. Today, approximately 8 billion human. But if 28 billion human, that means all the phage in the world going to make it as a human for 70 kilograms, that means going to be on Earth today, 28.6 billion people on Earth. This is the amount of the phage on the world. What about our body? Our body carry billions of phage, approximately 10 trillion, 100 trillion phage in our body. In the stomach, in the intestine, in the stool, on the hair, everywhere. The phage weighing in our body approximately 0.00 gram from 1 milligram of the human weight. 1 milligram of a human weight, there is approximately 0.001 gram of the phage. That means we are covered by phage. Is it good or bad? It is good. Just imagine, without the phage in the world, in the sea, there will be only bacteria growing. And the bacteria will growing to be rotten water. Human will die. because the bacteria are going to take over everything. So God subhanahu wa ta'ala make the balance, creating the bacteria, creating the virus at the same time. So they are fighting together for the selectivity. So the phage is environmentally friendly. We carried by phage. We have phage. We eating phage every time from the vegetable, from the meat, everything. The phage everywhere. So it's not really something we're going to scare from it. The phage, it has head, it has neck, it has color, it has we call it like fibers, tail fibers, and it have a tail, and then have a needle for injection of the DNA or RNA. So the process you could see here, the injection and then biosynthesis of the DNA. So the phage, when you come to the bacteria, hijack the DNA of the bacteria and start to produce a sample. And I will give you a good example how it's going to be. This is another example. This is live from the microscope, electron microscopy. This is the phage attached to the bacteria. Then attachment required approximately about 2 minutes. Then they're injecting the DNA into the needle, from the needle of the phage into the bacteria cells. Then the bacteria cells, phage start to occupy and steal the information from bacterial DNA to make phage for them. And the phage has been started, and then the burst of the phage went out. I will give here something. Now we have the phage. The phage attached to the bacteria, inject the DNA. Then the DNA of the bacteria has been occupied completely by the phage DNA. Then the phage DNA going to give a lot of commands into the DNA bacterial to produce for them heads, tail, spikes, neck, and then ask the bacteria, ask the DNA to reassemble all the phage to make it one phage. So the head going to be on the neck, on the tail, and all the legs of the phage going to be assembled again. That only take approximately 15 minutes. Then what after the 15 minutes that been assembled, the phage start to get ready to get out. So they're going to command the DNA to produce choline enzyme. What does this mean? Going to make hole inside the cytoplasmic, inside the bacteria, to make a hole, this hole to allow the phage to go out. But they need another enzyme. They need another enzyme that means lysine enzyme. Lysine enzyme that lyes all the cytoplasmic and the cell wall for the phage to get out. That take approximately 40 to 50 minutes. This is a wonderful weapon. If you think about it, this is the most rapid cycle God create on earth. When you think about it, every time when I think about it, it's make me only say Subhanallah. Just imagine a segment of DNA, a compound and occupied the bacteria DNA to make factory. This factory going to produce approximately between 100 copy of this phage to 1,000 in a matter of 40 to 50 minutes. When this phage going to be outside, going to infect another bacteria, and as again going to produce the same number in 40 to 50 minutes. So this is a weapon that kills the bacteria continuous. So what we have here, today we have a market, a transportation underway. That means when you transfer or you going to exchange your goods, vegetable or meat, to other country, they require a specific paper that your food has no any antibiotic resistance, there is clean, there is no radiation, nothing like that. So the regulatory, then consumers. Then you have another global trade demand. They need to export any value or any good, go to be under a specific requirement from any residues or any bacterial. So at the moment, the potential application for the company worldwide, they need sanitization for hospital. Sanitization for hospitals, when using any detergent at the moment, we're using detergent in hospital, most of the detergent on the hospital is not going to work because there is a resistance for the antibiotic as well as the resistance of the insects. The insects in the hospital has been resistant to most detergent. So we have two problems in hospital. We have antibiotic resistance that stay in hospital all the time, and we have bugs that stay in hospital in the sewage all the time, as well as resistance. So we have a problem. We have a problem in the decontamination surface in clinics setting or environmental setting. Then we have a biofilm. The biofilm is a big problem at the moment in the world. In the industry, food industry, in hospital, in water, in the toilet, everywhere. The biofilm, that means the bacteria start producing some molecules, make them stay on the surface. Then they start accumulate and start to produce more and more and more of the cell on the surface that we cover just like a carpet. So when using any detergent, they will never ever penetrate the biofilm. So the biofilm, this is at the moment is a nightmare for the hospital, nightmare for pharmaceutical industry. This is the nightmare for even NASA. When they went to the NASA during several years, they discovered that there is a bacteria being carried by the astronomist. These bacteria has been attached to the capsules on their mission. When they returned back to the air, they found that these capsules contain a lot of biofilm of this bacteria. And believe it or not, this is more resistant than any bacteria they found on Earth, because they are exposed to very hard condition on the mission of the ultraviolet and sun rays that cause them a lot of changing on the bacteria, so make them more resistant. So just imagine we have a lot of a problem, not only living here, but as well as for the people if they go for the long mission, if they want to go for Mars. This is another problem they're facing actually NASA. They think if 6 months take them to the Mars, what is going to happen to the bacteria going to be there? How are we going to get rid of them? There is no antibiotic, there is nothing of that. So this is a lot of worries, not only for the human living on Earth, for the food, whatever, but the problem is everywhere now. The platform agriculture we have, the design, what we have to build a flexible integrity into the long-term innovation. That means we have to think not only for the food process or the animal or the plant, as well as we have to think about one health planet, one health mission. So we have environment, plant, human, hospital, everywhere. Then the phage library cocktail, we have to produce a lot of phages, that these phages got to be ready for any disaster going to happen or anything in the future, or for the application, for example. The phage and probiotic, they're going to go together. At the moment, a lot of an animal farm, they not give them antibiotic as much as possible. Some factories, they give them probiotic. Probiotic does mean it helps the health of the animal in the gut, that stimulate the immune system of the animal and increase their immune system to resist the bacteria, as well as they give them small number of antibiotic, as well as they give them phage. So they combine phage, a small amount of antibiotic and probiotic at the same time. This is some of the pharmaceutical industry or some industry, they do that. Then we need to get the advanced delivery system. The advanced delivery system is very important. We cannot put the phage just like that, because the phage, when exposed to the UV light, going to be inhibited. So we have to consider the UV, have to consider the how to apply the phage in the open environment or to the human, and then the designing. going to be for the agriculture, for poultry, for food safety, processing, and environment setting. Phage at the moment, as we as applied bioresearch, we have uh, uh, two applications at the moment we're using. In our vision, we can use it for agriculture to target Xanthum ocidiomus or Erwinia bacteria. That all these bacteria has a potential on killing the plant, as well as you could make it as a spray or for seeding coating or the other application for soil. For the animal, we could use it for Salmonella, Campylobacter, Escherichia coli, and Biocontrol, or feed and water, and for egg sanitization. And for food safety, we could use it for cleaning the food or a process post-harvest the food and processing hygiene and getting to the surface as well to clean the surface of the food setting. When you come to the agriculture farm is very complicated. We have birds, we have air, we have rain, we have sewage, we have fertilizer, we have human, we have everything. This very complicated, complex environment. How are we going to control the plant from the any infectious disease, bacterial? If you're using any antibiotic, it's not going to work, because there is resistance. What are you going to do if you have something infection on the bacteria in the farm? Now we get example. Claviabacterium michiganus. This is a bacteria, very known bacteria that target the tomatoes, and as well as we have Pseudomonas syringae, and we have Xanthum campactus. This is bacteria deadly for the for example for tomatoes as example. If you think about the yield, bacterial plant disease, the economy burden or lose approximately a year between 20 to 40 average % reduction in affected area. A trade impact, I mean, if you have tomatoes or cucumber or anything that has a bacterial disease, they will stop it. You cannot really export it anywhere in the world. And then food security as well. That's another problem going to face. And global economy laws. Global economy laws for the plant disease, bacterial disease, approximately between 10 to 20 billion dollar a year. And there is no any solution for that at the moment. So we have the 10 to 20 billion US dollar that gone from the bacterial disease. So the problem not only in the tomatoes, another problem we're facing at the moment, Xylella fastidiosa. This is the bacteria, anaerobic bacteria, gram negative, and what it does actually, it carried by a vector bugs. That vector bugs make holes into the stem of the plant, and bacteria start to produce biofilm and block the water way, so the plant is going to die. And this is very, very well known, especially in Italy, Spain, many different parts of the world. The loss of European from Xylella fastidia, approximately 5.5 billion annual from one crop is olive, for example. So the olive actually, it's threatened by this bacteria. What we could do actually here, we have already way solution to do that. We're going to target, first of all, we have to target the bugs, because the bugs make the problem. Then if the tree infected and make a blockage of the water in the stem, we're going to get rid of this biofilm of the bacteria by inject the phage into the stem. Injecting the phage into the stem, they're going to lyse the bacteria in approximately less than 60 minutes. going to lyse the bacteria. But if we are going to use lysine enzyme, if I don't know if you remember when I show you about lysine enzyme, that another rapid bacterial antimicrobial agent that kills the bacteria in approximately 20 seconds, less than 20 seconds, can kill the bacteria. So we are capable to produce lysine enzyme. The lysine enzyme going to inject it into the areas where we could find Xylem fastidium on the plant. This approximately less than 20 seconds going to lyse all the biofilm and let the water go through to the plant. This is one of the way. When you come to the animal, there is a plenty of example I could give you on the plant, but I just select for you a few of them. Now for the animal farm, it's another problem. It's not only it's an open environment. Animal always going to be either sitting on the floor or in the dirty areas. So bird and insect, everything there on the animal in the farm. So you cannot really protect the animal just like when you protect a human. Human gets sick, you give him medicine and go to sleep and get well. But animal cannot do that with them. So if you give them antibiotic, going to be a problem, going to have multi-drug resistance. Now we come to the economy burden of the bacterial disease. The bacterial disease for the animal increase dramatically. And now we're facing a big problem with the antibiotic resistance as well as with the associated infectious disease, new infectious disease of the bacteria we have started. So we have a lot of, I could see, obstacle when using the antibiotic and what the disease associated with. So approximately we have 20 to 35 billion dollar a year lost of the animal disease because there is no antibiotic. And you can see plenty of bacteria challenge today, like salmonellosis. We have two types of salmonella. We have Salmonella typhimurium that cause a lot of damage to the poultry, and we have Salmonella enteritidis that goes to make a lot of damage into the egg industry. We have mastitis disease. We have plenty of other bacteria that cause diarrhea and lung infection. What we have done actually, we have produced or we have developed animal feed that has particles of the specific phage. For example, if you have a poultry industry and you ask me, well, we have a problem with the salmonella, or you need something to treat different infection of the bacteria in the bird you have, we could target that with the phage biotechnology. We have phage biotechnology. We are different than other people. Other people, they go to the sewage and they get the bacteriophage from the sewage or from the water. When the phage get weakened and the bacteria get resistant to the phage, they go again to the sewage, get it back, another phage, and do it. That's very costly and very simple way. What we have developed two stages of the technology. We develop selective phage. We have as well phage programming. So what we have a programming phage that make the phage killer, a machine killer for a certain bacteria. For example, if you need for salmonella, we'll give you for salmonella for your bird. So when you mix it with the feed, go into intestine into the gut. So any bacteria there are going to be cleaned approximately 1 and 2 days. So we have no any bacteria there at all. And then what we have the bird have no any bacteria for certain bacteria you are worried about. So this is another technology we have. We have developed Fogger. We are the first to develop this Fogger. The Fogger, this is a very advanced technology. I mean, you cannot go for every single bird. That take a long time and not really workable. So what we have a Fogger. This Fogger, if you put it in your chicken bar, or the animal barn, or anywhere you have for a room, whatever you have, when you open it, approximately open it less than about 15 minutes, you're going to be open all the time. 15 minutes open it, probably a day. That enough to kill every single pathogenic bacteria everywhere in that barn, from the hay to the wall, on the feathers of the chicken, or anywhere on the chicken on the surface. That we guarantee, because these are droplets, very tiny droplets. Each droplets carry approximately 1,000 particle phage. So this one particle phage is going to kill any bacteria you're going to see there. Of course, a specific bacteria. So this fogger, it has for different bacteria. If you need for Campella, will give you. For Salmonella, give you. For Salmonella, will give you. Anything you need will give you that, able to do that. So in this way, we could disinfect the whole area in one shot, approximately 15 minutes, and that been done. And every day, if you open it like 15 minutes, that would be enough. For egg sanitization, very important. Plenty of egg has some bacteria, special Salmonella enteritidis. Salmonella enteritidis, it's always associated with the egg from the chicken. That could penetrate to the shell of the egg and go inside, and then start to produce and grow again. Then anybody could eat the egg. It doesn't know have there is any bacteria in the salmonella or anything in the egg, so going to have some problem. So the idea is usually the egg cleaning by warm water from the industry, then they dry it. Then what we're saying, after you warm water spray, you just go through another warm phage solutions that can kill any bacteria on the surface, as well as the phage can penetrate inside the chicken shell. And if there is any bacteria there, going to be killed approximately within 10 to 15 minutes. So what we have complete clean, hygienic process, and the phage only killing the bacteria, not killing the human, not killing the plant, not only specific for the bacteria. For bovine industry, the bovine industry usually, before they milking the cow, or they send them for the slaughter's house, they give them warm wash. I don't know if they do that in the Arab country, but usually they do that in European and North America. We do that here. This is every day if they're going to milk the cow. So they give them some warm wash to clean them. Then after that, they go to milk the cow. Milking the cow continuous going to make some mastitis bacteria disease that injure the udder of the cows and cause them some problem. Then you have to use antibiotic again. Then antibiotic not going to work for Staph aureus. This is mastitis disease, usually occurred by Staphylococcus aureus. This is methicillin resistant Staph aureus, so resistant to antibiotic. Then the idea is, if you mix with the warm water the phage, then you have two things actually. First, the water clean the dirt from the cow, as well as going to kill, if there is a phage in the warm water, going to kill the bacteria on the skin of the cow, as well as on the dirt. So we have now clean, environmentally clean, no bacteria there, nothing at all, no worries. Then you're going to go for the process. This is why probably going to reduce the pathogen. But just think about it. The cow, they're going to produce manure. Do you know how much the cow produce manure? Manure going to be another problem here. The carbon footprint. This is the world at the moment, always a carbon footprint from the car, but they didn't think It's come as well from manure. I'm going to show you how the cow play very dangerous in global warming. So the manure going to make greenhouse gas emission from methane, nitrous, and carbon dioxide. I will show you how. Now just think about, in United States, approximately 180 million dry tons of livestock and poultry waste every year in the United States. 100 million. If you put this 100 million dry ton of the manure from the livestock and the poultry and put it in a stadium, football stadium, approximately 6 foot deep, going to cover, you need a 300 plus football stadium to cover all the manure produced by 1 year, more than 300. Just imagine how big you have in only one country, United States. Just imagine about China. Just imagine about India, where the approximately two countries, approximately they have 3 billion people there, and how many cows they have there, and how many chicken they have there. So the problem here, if you think about it, it's not only from the car. If you think about it, why come all that amount of the urine, of the manure? Because of food stimulant antibiotic. They make the cow fatter, more yield to produce, more manure going to have here. So the problem here, the manure contain a lot of antibiotic. Just imagine antibiotic resistance, and where going to be this? Going to be on the air. I'll give you a comparison. 180 million dry tons of manure from United States. That's equivalent to 191 million cars on the road. 200 million car on the road give you less footprint, carbon, less than the 180 million dry tons of manure. That means the manure of the cow more damage caused than the car. Just imagine that. But nobody tell you about that. But this is the problem. I just want to show the problem. Where is it? The problem, how going to get rid of all that? If you have all that amount of manure going to go produce all that you have for methane, nitrous oxide, carbon oxide, dioxide, where going to be this? Going to be changing, climate changing. How are we going to fix that? Actually, we fix that in a way in small animal models. If you're going to give the cow phage specific to get rid of the methane or from any fermentation later on into the cow, then when you have a manure in the farm, just add a phage into the manure. So the phage into manure going to be degrade the amount of the methane, going to inhibit the production, the bacterial production for the methane. So you target bacteria produce methane. One. Second thing, if you discard the bacteria produce methane, then other bacteria produce nitrous and the carbon dioxide, as well as going to target other bacteria. All these bacteria is not any benefit to the human. Actually make more problem into the global warming. So we could target this bacteria in the manure. Then what we have a clean manure, empty from any methane gas or carbon dioxide or nitrous oxide, as well as clean from any Escherichia coli that caused dangerous or salmonella. So what we have a clean environment. So we return back to the clean environment. This is actually happened before the discovery of antibiotic. How the human have been healthy in the past because of the bacteria and the phage. So when the farmer days ago, before the using an antibiotic into the animal, they were very happy. There was nothing really on climate change or anything, because when the industrial start to increase using antibiotic into the animal, now we start to decrease the global warming. The global warming not come from the car only. The global warming come from the cow. Just imagine how many country in the world they have cows or chicken, dirt, and that all going to make global warming.
دكتور فراس عند كلام لك دكتور.
Dr. Jason, Prof, how much time do you want to finish your presentation? 10 minutes or?
Two slide.
Okay, I'm so sorry for that. Sorry to step you.
Okay.
Go ahead.
So our mission now to return back to the phage biotechnology. Phage biotechnology got to create on Earth a phage for the human, to use it for the human, for the benefit of the human. But when we return back to the industry and get the antibiotic resistance and involve the give antibiotic to the animal, that has caused a lot of a problem in the world. Our idea is how to go to the phage biotechnology in the Arab world. The Arab world at the moment facing a lot of a problem. The problem is the drug resistance bacteria, the food security, the global warming, that always there. But we have to think about how we're going to get benefit of the phage biotechnology from the farm to the fork. Thank you very much.
Thank you so much for your amazing presentation, Professor Sabah. And now we will open the discussion session. For anyone, you can raise the electronic hands or directly ask Prof. Sabah about anything.
خليني أبدأ أني.
يلا انت بروف ابراهيم واذا ما بعدين عندي انا مجموعه من الاسئله ان شاء الله.
Thank you, Dr. Sabah. Thank you very much. Thank you. It was very interesting, but unfortunately, it's more oriented to veterinary, not for agriculture, for plant protection. But anyway, part of it, you handle some of the problem of plant protection. Yeah. I will go first for the Xylella fastidiosa and olive. The insect is a sucking insect, not inside the trunk. So this the insect insert the saliva in the plant, and then the bacteria transferred systematically. This is the Xylella fastidiosa in Italy, and the number is 6.5 million trees have been demolished. And they spend every year around 20 billion for controlling or for at least suppressing the dissemination of this disease. The second question, I mean, what is the formulation of the phage? You can use it, for example, for Erwinia. You mentioned Erwinia and Pseudomonas and the Xanthomonas. So what is the formulation we can use it actually?
Spray using on the liquid spray. So what we have the get the phage, for example, and then get program the phage, and then get selective phage that killing the bacteria rapidly. Then we will introduce it as a spray. So just spray the tree or spray anywhere on the, as well as you could put it on the ground. If you water the agriculture, you could put it on the ground as well. Not going to be very expensive, because what we have like approximately 10.6, I mean approximately 1 million particles per 1 mil of water. That's enough to target the bacteria in approximately less than 15 minutes. Then they're going to die approximately 40 to 50 minutes. Then you have no any bacteria on the surface. If you want to inject it for the Xylella fastidia, you could inject it. into the stem and get rid of the bacteria as well, because that causes another problem. You're not on the surface; it's going to be inside the arm,
Yes.
in the trunk. So we do it in this way.
systematic.
Yeah.
Go on.
Yeah.
دكتور أنت دكتور فراس عندك سؤال.
دكتور إبراهيم إذا بدك اعمل مداخلات، أنا عندي a couple of questions بس you can continue no problem at all. ولا بعد
أنا الحقيقة دكتور صباح يعني I get worried. يعني هل إحنا طبعا أنتم عندكم في كندا وفي أمريكا أكيد، هل إحنا كل يعني اللحم دجاج والهذه كله treated with antibiotics؟
I can't
هذا
say that.
يعني هذا
I don't know.
يعني
I don't
دوختنا
know.
اليوم.
I don't know about that, but you could take it the figure from the Minister of Health for each country. I mean, just imagine how many people they get infected by bacteria when they eat food. For example, I went to one country. I don't know what is the name of the country. I get in approximately 10 days, I get diarrhea in 10 days 2 times. Just
That's
eating
salmonella.
salad. Just eating salad. Salad.
Yeah.
And a good restaurant, to be honest. I mean, very good restaurant. Not on the street. So just imagine. Yeah, so I mean, antibiotic everywhere, antibiotic. This is a problem. The problem, antibiotic everywhere, and the resistance everywhere. You look, the problem linked to the cancer as well. I don't want to scare everyone. I'm a biologist. When you look to the spectrums, why a lot of cancer, gut cancer, colon cancer, concentrate in the Arab world? Concentrate in the Arab world. Just think about it. Because of the antibiotic resistant. We discover some bacteria cause not direct cause of cancer, but one of the factor cause the cancer. H. pylori, Helicobacter pylori. This is everywhere. That cause cancer, colon cancer. Just imagine, many people have colon cancer. Huge number.
So why you don't release your product as I mean on shelf product as a disinfectant? If the case is so, then we can dip the for example the vegetables, or when we buy the eggs, we can decontaminate the eggs or whatever we have, because this is the way that you shower the complete bin. That it will be very good.
Yeah, I tried it with the Arab country. I don't want to give the name, but
Saudi.
No, not really. No. They get scared. Told them, look, if you go to the lab, I will get you phage from your nose, from your mouth, from your stool, from your body, everywhere. The phage everywhere on you. Why are you scared from the phage? Why the phage not kill you yet? Why are you scared from the phage? If I put the same phage, I get it from your body, I put this phage to kill the bacteria in the cow. What the difference? Where is the problem? He said, no, because security. What the security? Dr. Ibrahim, the problem in the Arab world, the education. I present this presentation because I have a very bad experience when I first presented phage-based technology in the Arab world 1 year ago. Honest to God, the people say, oh, what are you talking about? This is too dangerous. Oh my God, what too dangerous? What is dangerous? Then I put this presentation to show you how many elephants go to make from the phage. The body, how many phage. This is not necessary to present that to you, but I want to show how much phage we have involved everywhere. So I couldn't really do anything in the Arab world. I tried to help. I tried. But to be honest, the problem in the Arab world, I could see it from now, going to be increase, especially in the food security. The food security is alarming. Alarming, really alarming.
I agree with you.
Thank you very much, Dr. Firas. Thank you. It's alarming.
Okay, let's start. Prof. Sabah, I have a couple of quick questions for you.
Please go ahead. Fire.
The first one, do you think that rapid global warming that we notice today will affect the effectiveness of the using of bacteriophage negatively? Because as we know, it has already started accelerating and rapid, and the temperature will increase. What I mean, temperature increasing and the CO2 increasing. Do you think, especially increasing in the temperature, will affect the effectiveness of using such a technology or innovation, whether in livestock or against controlling of some, as you mentioned, insects and diseases?
I got
This
your
is the
answer.
first one.
Okay. I got your answer, question. Very, very clever question. Thank you very much, Dr.
Thank you
Faraz.
too.
You see, I work with the phage biotechnology approximately now over 35 years. To be honest, the best phage in the world, you get it in the Arab world. If you ask me if I could get phage from Canada, do you know how many days we have warm days in Canada? Approximately, if you collect all the 365 days, maybe we have like at the most 40 days. At the most 40 days.
Fewer days.
Yeah, 40 days, no more than that. Then after that, cold. Then the phage need warm weather to infect the bacteria. So that means our phage in Europe, anywhere in the world, cooler, the phage fighting the bacteria is less. When you come to the Arab world, the warm weather, the dirt, a lot of dirt, I'm sorry to say that, a lot of dirt, a lot of unhygiene process in the Arab world. And just imagine how many millions of years human has been lived in that area, more than Europe, more than anywhere. So this accumulate a lot of tradition and historical phage from that area.
This is why we are living. This is why we are living. Because the phages. Yes.
So this phage actually, it has a lot of tools, has been strengthened from any global warming, from radiation, for anything. So no, they will be excellent. They will be excellent. No worries.
Alhamdulillah. Okay,
Alhamdulillah.
the second question, quickly, inshallah. Do you think that the
دكتور عندك
intensity
قبلك عندك في سؤال واحد رافع ايده بعدين
في
انت.
عنا دكتور عبد. تفضل دكتور عبد الله.
عبد الله.
عبد الله. تفضل دكتور إذا تسمعنا دكتور. عامل ميوت دكتور عبد الله سلوم.
كمل سؤالك انت الثاني احسن.
دكتور صباح في السؤال الثاني. Do you think that the intense use of micro or bacteriophage with the time against or in order to control many diseases, whether livestock or pests or insects, will develop resistance or these pests, or with the progress of the time, since it's well known for us that the using of Bacillus thuringiensis since 1911 has already started, and there's some reports from different countries that this bacteria has recently developed or many pests develop resistance against such a bacteria. What I mean, do you think that the use of such technology will be resistant by, for example, insects or diseases, or by these cows or livestock, or the situation will be okay for it? I didn't know. if you understand my question or not.
I mean, if well, I understand your question, whether the antibiotic or detergent has more accumulate more resistance to the insects. That's the question.
Yeah.
No,
Or
the
the
question.
insect will develop resistance
Yeah,
against bacteriophage with the intense use and with the progress of the time.
if I correctly understand your question, anyway, if your question directly whether it's the bacteriophage get resistant from the bacteria, yes. The phage always the bacteria that are very clever. They could get mutated from the bacteriophage, and this is all the company in the world. If you go to Google, they will tell you two things. If you have resistance of the bacteria, you have to go to the sewage or to the toilet or dirty area and get sample, go back again to the lab and do your work and get the phage and put back again. And this is the old days technology and still has been used in 2026 today. What we have done, 1992, we have the problem. Then I discover a way to virus selective. We are the first in the world to select, breed the phage. You could breed chicken, you could breed cows, but you cannot breed phage because phage, single double DNA, you cannot breed it because there's no cell. It's not a cell, not complete. But we breed it. And that we have a patent application worldwide. Then 2010, I discovered another way to reprogram. That reprogram, what does it mean? I learned that when the bacteria get infected by phage, so they leave the phage some segment into the DNA of the bacteria. The bacteria get more clever to get out of this segment and make resistance to it. Now, what I have learned from this technology from the bacteria and phage, we call it phage programming. What does it mean? If the bacteria program their DNA in a way that understand how the phage can avoid it, then why not do it in the test tube? Then I done it in the test tube, and we are successful to reprogram the phage. That means the phage never ever get resistance from the bacteria. The reason is why the bacteria need approximately, the phage need approximately 15 minutes to occupy the DNA of the bacteria and do the job. And we made it approximately 5 minutes. So there is no time for the bacteria to get resistant. So come 5 minutes and occupy the DNA of the bacteria and do all the job. And the bacteria, there's no time to get resistant. If this is if I answer your questions.
Yes, good
Thank
explanation.
you so much. معنا now Dr. Abdullah Salloum.
Yes, Prophet. Did you hear me?
Yes.
Yeah.
Yeah, thank you so much for this educative session. My question is on plant protection. And the question is like this, the wheat bacterial diseases and their control management strategies in plant protection.
Your question once again, please. I don't know if Prof. Sawad get the question from Dr. Abdullah Salloum.
Wheat bacterial diseases and their control management strategies in plant protection.
He asking especially in wheat, how he can control that bacterials like in wheat.
How would you call? Not only wheat, not only
In general, Professor, in general, like the crops and vegetables. Also like you mentioned that it started from the bacteria, start from the insects. How I can, so I should control and manage the insect itself, or also the weather caused that humidity and temperatures caused some of the bacteria. So how I can control it without using the fungicides or pesticides in general?
So your question two ways:
Yeah.
how to control the insects and how to control the bacteria in the agriculture farm. Correct?
Exactly.
Okay. The bacteria, we know how to control it from the bacteriophage, so we could develop many bacteriophage. By the way, you could make a cocktail of the phage. So we not make only phage for one bacteria. For example, your farm, very big farm, and you want to get rid of as much as possible of the bacteria you have in the farm. These bacteria, you know them that they're going to kill your the crops. We could develop for you cocktail. Cocktail, that means put 4, 5, 10, 20, 100 phage, different phage, kill spectrum, big spectrums of the bacteria that infect the plant. This is the done. Regarding the insects, Dr. Ibrahim, he knows that I was discussed that with him once, maybe last year or a year before, if you remember, Doctor. I know, I know that. So we could use the virus insects. For example, red palm weevil is a big problem in the Arab world. It's
Now
very
they'll come
easy.
back. They come back now to the bacteria, Bacillus thuringiensis.
Yeah,
Now they-
but yeah,
1.5%. Yeah.
yeah, but you know, the red palm weevil much better to use them. I use the enemy for my enemy. I will use red palm weevil to target where palm weevil itself. If we have a virus, there is plenty of virus to kill red palm weevil. If we put the virus in the guts of the red palm weevil and put them on the tree, I know the bugs, they have a gut in their gut. This virus is going to kill them, eventually kill them. Eventually will kill them in approximately 24 hours. But once they go inside the hole, because they know the hole, we don't know where they go. They will know. They go to their community. When they go to a burst, going to be a lot of virus going to be there. They want to kill all their community there. So this is one of the way can be done. And this is the very safe way to do it. I don't know why nobody moved to that one.
I mean, this concept is not very easy, but we have to discuss it again. This is not not now.
It has been done. It has been done. See, I met a professor in the United States approximately 20 years ago, and he have the technology. I didn't know about it, to be honest. It's not my technology. I transferred the technology from that person. He told me and he showed me the virus. And I learned, and he teach me a lot. I didn't know anything about it, to be honest. He teach me a lot, and I know how to do it. And he done it in California. It's not that difficult at all. And so return back to the question. Yes, you could target any insects probably by the virus, but you need a lot of approval from the government protection agency. Plenty you need, but I don't know that this can be done.
Professor, usually we use methods and selection methods and breeding to pass these things, but it's take a lot of time to improve a crops that it has the unique version like F1 or maybe the parents, the lines. We do it, but the problem is take a lot of time, and the result, yes, we don't we if even if it's the insect attack the plant, the virus, the bacteria will do nothing, because we have worked about it. Like we use the selection methods, we use a good or a unique populations. Like we selected. Yeah, actually, in my PhD, I used selection in mass positive negative. Like any plant shows any infection, we remove it, we eliminate it in order to get the resistance plants. Or so that thing takes too much time, and we need to do it more and more times, more than once. So this is the method we use it at the universities in general. Like
Thank you, Dr. Abdullah. We will move now to Dr. Mohammed. You can ask your question for Prof. Sabah. Dr. Mohammed.
My question is, what is your opinion regarding phages can interact with animal immune systems, sometimes modulating inflammatory responses such as decreasing pro-inflammatory cytokines in salmonella-infected chickens, make some of, we can say it like interaction with the immune system. Thank you.
I'm not really the clear. I mean, what you want, phage or the immune system, the cytokine and immunization. What the question exactly?
Yeah, but my question exactly is some studies talking about phages can interact with animal immune systems, and this occur and happened in salmonella infected chickens.
Oh, yeah, I agree. I didn't talk about phage therapy. I talk about phage biocontrol. There is two things. Very good questions. If you see in the phage biotechnology, I never ever touch phage therapy. I disagree with the phage therapy completely because you're going to get immune system resistant. So you're going to lose your money, you're going to lose everything. If you inject the phage into the human or into the cow, then you're going to create immune system resistant, and the phage going to be done, finished. It's going to work. I'm talking about the biocontrol. Biocontrol, prevention before it's happened, the disaster. Reducing the antibiotic. So I will put the phage in the biocontrol, in the water or animal feed. If they go into the intestine, they not go inside the body, intestine. So going to clean the gut. That different, no therapy. This is biocontrol. So I didn't really introduce it into the human, into the animal blood system. That completely different. So yes, if you introduce the phage into the animal system, blood system, yes, it's going to induce immune stimulant. And that, too bad, not going to get any benefit. But we talk about phage biocontrol. Phage biocontrol is different than the therapy.
Thank you for your answer, but is there any possibility to, during the protection, to the phages to invading the blood system or bloodstream?
You could do it, but I disagree.
Yeah.
I disagree completely. You see, approximately all the companies in the world, they talk about phage therapy.
Okay.
Phage therapy is not going to work. I'm telling you now, not going to work. I know company. I know. I'll give you an example. I know a company. 2005, they contact me and they told me about the phage to help in the phage therapy. I told them, no, I'm doing phage biocontrol. And I give them why I am not involved in therapy, because you're losing your money, you're losing everything. To be honest, they put $25 million. The company, in 4 years, they lost everything. Everything. Because the well known is, if you introduce any antigens into your cows inside or anybody, going to get resistance. The immune system, immunoglobulin G, going to be attached to the phage, and macrophages and the leukocytes going to engulf the phage. So why put it to start with?
Yeah. Yeah, thank you. But actually, the livestock production in poultry, phages are used in poultry to improve gut integrity and clearing nutrient digestibility and reducing the mortality from bacterial infections.
Yeah, in water on animal feed. That biocontrol.
Yeah.
That biocontrol. That different.
Thank you, Prof. Thank you.
Prof. Sabah, I'm so sorry for that. We have a couple of questions on chat, and it would be high appreciated from my side if you can answer them quickly, because there are many, And for Professor Ibrahim, I'm so sorry for that, Prof. Salah. If you'd like, you can pray Maghrib and come back, and this is up to you. You are my big boss. We have a couple of questions, and hopefully we will finish this seminar within 10 minutes. The first one, Prof. Sabah, the first one, how can we decrease the race resistance with a minimal cost? This is a question from Ala Gidan from Jordan.
How to reduce the drug resistance?
Or
Is it-
race resistance with
Rate?
race.
Yeah, rate resistance of antibiotics.
She has written race resistance or rate resistance within a minimum cost.
Okay. I mean, to reduce the rate resistance, use bacteriophage biotechnology, or you have to. I suggest that to different country, but nobody really listen what I'm saying. You have to make map gene modified or gene multi-drug resistant map. Any country in the world they have a gene map of the gene resistant. According to this map, the Ministry of Health, they go to order the antibiotic for the second 20 years because they know exactly what they're going to face in the future. If this is going to be, if this is going to be in every Arab world, they're going to reduce the rate, but nobody work on that. You have to put a roadmap. I mean, if you go anywhere in the world, I mean, country already developed, they have a map. They have what antibiotic going to get. The antibiotic come to the Arab world just like give me this antibiotic. Okay,
OTC.
Exactly, but think about the resistance you have, the rate of resistance you have. So what you're doing, you enrich the pharmaceutical industry and you enrich the pharmacists in your country, but the antibiotic not working. Then why I have to get this antibiotic to the community, and eventually they're going to be more resistance. It's not useful for the human, not useful for the patient. I mean, but it's good for the pharmacist and good for the company. So you have to put gene map. I haven't seen this gene map.
Okay. Can we have another question?
أقول خلينا بالباراسيتول.
حي دكتور الله يبارك فيك. Prof. Sabah, another question. Do you think, or what's your opinion regarding, do you think that phages can interact with the animal immune system? If you have a quick answers in order to finish some couple of questions in front of my eyes in the chat.
Okay, I repeat. If you're going to use the phage as therapy, what does it mean? Inject animal with the phage, not going to work. But if you go to make it biocontrol, that means I control the phage in the gut or on the surface. Then I go to reduce the antibiotic. I go to get or give it to the animal. So there's a way to do it. Biocontrol different than therapy. Therapy is going to interact with the immune system of the animal. But if you give the phage as a biocontrol to control the gut and outside of the animal, then this is your target. This is what you need, actually.
Okay, Prof. Jassim, Sabah, someone wrote here, no, Arab countries generally have lower cancer incidence rate compared to many other parts of the world, particularly Western nations. What's your opinion, quickly, please?
I don't know what the question. Sorry.
عدد الناس المصابين بالسرطان بالدول
السرطان
العربية
في أمة
يقول
الغرب
أقل من الغرب.
عند العرب أقل من أمة الغرب سيدي بيقول لك. Your opinion.
Okay, I didn't really make a comparison, but I took colon cancer. Maybe other type of cancer, yes. I'm talking colon cancer, breast cancer. This is huge, huge. And this is due to the pesticide, fungicide. I don't want to mention the name of the country. One of the
No need to mention anything.
one of the country, they have 60,000 death of the people using pesticide and fungicide every year. Farmers, 60,000 because of the cancer, abortion, what you call it, defect, infertility, breast cancer, and colon cancer.
Yeah, it's from pesticide and others.
Yeah.
And the last question for the webinar today, because he is insisting from, I think, Abdullah, and he is already asked you directly. Could you answer for me this question, the wheat bacterial diseases and their control management strategy? I think he has already asked you this question directly.
So, don't know, sir, what question?
I think دكتور، هذا سؤال معاد من الدكتور محمد، انه يسال عن اللي هي المانجمنت اند بيست، واتوقع انه سالك مباشره. وفي عندنا اخر ملاحظه انه طلب احد الحضور كانت المحاضرة باللغة الإنجليزية، ويعني أفضل. يعني أنا نظري واحترامي للدكتور محمد، ما بعرف، هي بشكل عام أغلب السيمينارات عنا احنا سواء في أمة الغرب العالم العربي هي تكتب باللغة الإنجليزية، ويعني جل المراجع حقيقة، أنا في معلوماتي البسيطة أنه 95 أو إلى 99% من جميع المراجع العلمية موجودة باللغة الإنجليزية. ف why not if we present and talk in English language، ويعني both are the same. ويعني نلتمس منه وإياكم أخي الحبيب بروف حقيقة صباح، نلتمس منه عذرا أن المحاضرة كانت باللغة الإنجليزية، ولكن يعني البروفيسور حقيقة صباح هو من 40 50 سنة هو عايش في اللي هو يونايتد كينجدم كندا، يعني في دول الغرب، فهو ارتأى بأنه يعني متعود أن يتحدث باللغة الإنجليزية، فأجزنا له ذلك. يعني حقيقة ولا ضير في ذلك، سواء كانت عربي إنجليزي فلا ضير. على كل حال، وفي نهاية هذا اللقاء الأستاذ الدكتور صباح، جل احترامنا في الآرينينا وتقديرنا لهذه المحاضرة فوق الرائعة. يعني أنا إذا قلت لك رائعة فأكون حقيقة قد قصرت معك. يعني أدخلتنا في موضوع رائع جدا، ذهبت إلى الأورام السرطانية تهتم في صحة الإنسان، ذهبت لنا إلى اللايف ستوك، الى حتى البورتري سمول رومينانس، ذهبت لنا الى البلان بروتكشن. فانت نوعت لنا في هذه المحاضره ودخلتنا حقيقه في امور كثيره جدا في استخدام اللي هي الفيروسات، خلينا نسميها، لمكافحه البكتيريا. ويعني حتى الطريقه، وانا والدكتور ابراهيم كنا بنعمل مداخلات اكثر، ولكن الوقت لا يسمح اللي هي الريد بالم ويفل، وهذه تسبب مشكلة كبيرة جدا في العالم العربي حقيقة، وتصيب النخيل. ولكن لضيق الوقت لا نريد. أنا حبيت، كنت بدي أعمل تعقيب على هذا. أنت حكيت أنه يعني أنت شفتها وناجحة، قد تكون بالمختبر ولكن بالبراكتيكال ويا حبذا. يعني جل العالم، والدكتور إبراهيم هو أستاذي حقيقة ويؤيدني، يا حبذا أن نجد new innovation or technology in order to control and suppress اللي هو the red palm weevil. هذا يحدث خسائر بمليارات الدولارز حتى سنويا. السعودية بيشتغلوا عليه بكثرة. شكري لك على هذا الوقت وهذا الجهد، وشكرا لك سيدي وأخي البروفيسور الغالي علينا أن يعني أعطيتنا من وقتك ومن جهدك، وهذه المحاضرة حقيقة يعني محاضرة رائعة جدا، قيمة جدا، وإن شاء الله سبحانه وتعالى راح تنزل على اليوتيوب، وراح نبعث لك اللينك تاعتها. دكتورنا العزيز، حضورنا الكريم، حقيقة أتوجه بجزيل الشكر لهذا الوقت الذي يعني منحتمونا إياه، ويعني لهذه المحاضرة القيمة الثمينة هذه. يعني دكتورنا الغالي والأستاذ الدكتور صباح حقيقة قدم ما لديه، وحقيقة هي أغلب المعلومات. أنا كشخص بالنسبة لي يعني نيو انفورميشن، يعني نيو نولوج حقيقة. فيا حبذا أن تكون هذه المحاضرة دافع لنا جميعا للتفكير في هذا الاتجاه. على الله أن to introduce and start applying such new innovations and technology in the Arab countries. وهي بالأخير لصحة الإنسان، للبيئة، لأمور كثيرة جدا. عرج على نقطة رائعة جدا، ولكن الوقت قد داهمنا. قضية الكربون فوت برنت وسي او 2 ان 2 او والكربون عشان الجلوبال وورمينج. الوقت لا يسعنا، ومعنا دائما احنا المراقب الوقت ما شاء الله استاذنا الكبير البروفيسور ابراهيم الجبوري. يعني والا والله ان النقاش في هذه القضايا رائع جدا لتبادل الخبرات. أخي الحبيب بروف صباح، تعجز الكلمات حقيقة عن شكرك كعالم جليل، وهذه يعني المعرفة والعلم الذي تحصلت عليه خلال ال 35 سنة الماضية من حياتك بين وانتقالك بين العديد من الدول. فلك منا في الأرينينا ومن معالي الأستاذ الدكتور رضا شبل خالد، وأنت تعرفه جيدا، اللي هو الأمين التنفيذي، من مساعد الأمين التنفيذي الذي أنجزت، والآن هي مراقبة وموجودة معنا المهندس رايا، والحضور الكريم. يعني وجودكم كذلك أثرى هذه المحاضرة القيمة. خالص الشكر لكم. أسأل الله العظيم رب العرش العظيم لي ولكم أن نكون عونا لشعوبنا حقيقة، على الله للوصول إلى أمن غذائي. ودمتم وطبتم، والسلام عليكم ورحمة الله وبركاته. السلام عليكم، ونترك الراية إلى المهندس راية لإنهاء هذا التسجيل، وسيصلكم جميعا حقيقة على الجروب والبروف صباح عن طريقه وعن طريق المهندس راية إن شاء الله اللي هو اليوتيوب، وإن شاء الله within the coming 2 days maximum بإرادة الله. طبتم وسعدتم، والسلام عليكم ورحمة الله وبركاته.
Thank you.
شكرا.
وعليكم السلام ورحمة الله
وعليكم
وبركاته.
السلام.